positive increase, there's a positive trend, and we can see there's a random movement. And then for cyclic, we learned that for cyclic variation that the period is not fixed. So if you see in the graph also, the graph is not a fixed period. So it's this irregular, but if we can see it's a cyclic graph. As for seasonality pattern, we see that the graph is fixed. Like I gave you the example of the gift shop. Like every December, we'll see the pattern of increase in the graph. So this is a graphs, and then there's another graph when we see trend with seasonal pattern. So this is the graphs, and these are the components of the time series. So our next topic is stationarity. So stationarity is one of the important factors when we are working with a time series or when we are dealing with it. So it can be defined as time series is set to be stationary if there's no change to properties over a period of time. So it implies taking consecutive samples of data of the same sizes, and that should have some same covariances and identical distributions. So from the name itself, we see that stationarity. So means no change at all in the graph. We see that the graph is the trajectory of the graph is same for different time periods. So this is one of the important factors when we consider if we want to see like how a business works, so like how is the progress of a business. So when we analyze the graph of a business in a business, so if the graph is if the success of the progress of the business is a stationary graph, so people will be able to analyze it. So that's why it's an important factor. Moving forward, conditions for stationarity. So for the graph to be stationary, so we need to see three factors. Keep in mind three factors. So the mean of the time series should be constant over the time, and hence if the mean is constant, there will be no trend at all. So the graph will be exactly the same. Second point is the variance should also be constant. So there shouldn't be any change in the value of the variance when the graph proceeds. And data should have consistent covariances between the period at an identical distance from one another. So some of them might be confused with what is covariance. So we'll move forward to some covariance, the definitions like. So covariance is a statistical tool that is used to determine the relationship between the movement of two asset prices. Like for example, when two stocks tend to move together, they are seen as having a positive covariance, and when they move inversely, the covariance is negative. So sometimes for different stock, sorry.
Tejas, can you stop over here for a second?
Yes, sure.
Yeah, I just want to ask a few this thing. So everybody who's on the call, can you just tell me? This is slightly, it's let's say it's a intermediate level kind of a topic. It's not something which is very basic statistics also. To my knowledge, it is taught only in BSc stats or things like that. So some of us might not be aware. So from a conceptual point of view, are you able to understand what he's going through? Are you at least able to understand the concept, yes or no, or it is going totally like we say bouncer, it is going bouncer? I hope that's not the situation. I'll ask you one by one. Abhishek, are you following what is happening?
Yeah, I'm following.
Great. Akshat, Akshat vanished suddenly. Rachit is saying he's okay. Tapendra is okay. Yeah. So perfect. So yeah. So as long as yeah, we are fine. So great. When we say correlation, so I just wanted to kind of button over here. When you say asset prices correlation, uh, asset prices correlation is a very far away kind of thing to think about. Let's say you want to understand the correlation between humidity and the sunlight during the rainy season, right? So in the early morning when there is less sunlight, the humidity itself will be quite less, and as in the afternoon the sunlight increases, the humidity might increase. In the night again the humidity might be less. So there we can see that there's a positive correlation between those. Okay, and similarly, it is also possible that a organization's stock price goes up, right? No issues, Akshat. That is okay. No problem. Organization's stock price goes up over a period of time, and there are other performance targets in the organization which have gone up. So while we all are sitting outside the organization and looking at the market, and we see the stock price is going up, there must be something internal to the organization which is might not be known to us. We might not read the news or we might not be aware, but there will be something internal to the organization which would have uh, actually gone up. To take a recent example, because of this COVID, a lot of people have started using Zoom for meetings and all, and suddenly the stock price of Zoom has gone up. And then they got into some issues recently, I think, with regards to security and all that stuff. That is okay, but that is besides the point. But because there is a demand in the market and there is somebody who's ready to supply at that point in time, and the demand increases, the supply increases, the stock price goes up. So that's what he meant with a positive correlation over here. Is that correct, Tejas, or am I wrong?
Yeah, absolutely correct.
Yeah, so that is one thing. Earlier things that you have shared, in case anybody wants to repeat something or anything, you please keep looking at the chat also, because I think you missed a couple of chats earlier. Thank you so much. You please go on.
Okay. So moving forward to there's like how to check whether a graph is whether it is stationary or not. So there are some tests to check stationarity. So one of them is rolling statistics. So rolling statistics plot the moving average or moving variance and see how it varies. And it's a visual technique. The next test is ADFC or Augmented Dickey-Fuller test. So it consists. This test is like how a hypothesis work in statistics. So like it consists of null hypothesis, which says that time series is non-stationary, and the test results. And when we compute the test, so the results comprise of a test statistic and a critical value. So if the test statistic value is less than the critical value, then we have to reject the null hypothesis and we go for an alternate hypothesis. That is time series is stationary. We'll be going through this tests in our Jupyter notebook. So our next topic is autocorrelation. Autocorrelation is also we should keep in mind this topic when we are dealing with time series. It's also important as compared to the stationarity. So it is defined as the correlation of a time series with a time lag. Here, time lag is defined as the period of time between one event and the another. It shows that whether previous values of the time series has an influence on the previous values or not. It is also commonly used to check if a time series is stationary or not. A time series, if we there's another point of stationarity. A stationary time series will have a autocorrelation fall to zero fairly quickly, but for a non-stationary series, it drops gradually. So here there's a graph over here. Uh, the indexing is not really good, but if we uh, properly observe this plot, we see that the 10th value, which is over here, the 10th value is and is equal to almost equal to the 20th value, and same with 20th value to the 30th value and 30th value to the 40th value if you properly analyze the plot. So if we observe, this is the observation. Like from the plot, we see that the 10th value and the 20th value have a high autocorrelation. So it basically tells us like how our like the periodicity of our graph, like after every time period, we'll find the same value. Then from at the other time period, we'll find the same value again. So this is how autocorrelation works. So we come to the end of this PPT. I'll now share my Jupyter notebook to you. So we'll get to know how we will able to present these topics while when we are coding it. Give me a second, guys. Is my screen visible right now?
Yes.
Okay. Is the Jupyter notebook visible right now?
Yes, it's visible.
Okay, great, great. So right now, so here I prepared a Jupyter notebook. Like this notebook consists of the small data set which consists of the passengers for a particular month, the flight passengers for a particular month, like how many passengers have flown for a particular month, which is from the year 1949 to 1960. So this is our data set. So I'm importing the libraries, necessary libraries. Importing necessary libraries, and then I'm loading the data set also. So here we see that the month and the respective month and the respective passengers, the number of passengers. And then we go to check the data set. If we check our data set, so our month is right now in date and time format. So wait, just a minute. Earlier it was in the object format. The object in format means it is in the string format actually. So we can't perform any analysis or any analysis on the data. So this is our code for here. Like I'm changing the month. I'm changing the month column to and to its data time format, and I'm setting the index of the data as month. So if we run this, we get the month as the index of the data frame. And this also tells us the index. Now I'm taking another variable like time and I'm retrieving the passenger passenger value, and I'm getting the values of every month and the number of passengers have been that have flown in the flights, and I'm plotting it. So in this graph, we see like this graph is an increasing trend, and the times, like clearly you can see the graph is increasing. So our time series is not stationary. It's not stationary at all. Like from the definition, we've seen that stationary means all the statistical properties should be same and should be constant over the time. So here we see that there's a trend, increasing trend. And then from the graph, so we have to check the stationarity of this time series. So there, like I've said, there are some number of tests. So here we'll be implementing the rolling statistics format. So if we see the rolling statistics format, I'm finding the rolling mean and the rolling standard deviation of the time series. Like from this code, if we see, and from the code we see that I'm finding the rolling mean and rolling standard deviation and printing it. So we get the values for this passengers and the months, the standard deviation, and then we will plot the statistics, and we plot the graph. Sorry. So clearly, if we analyze from the previous graph, I've added the mean and standard deviation. Sorry. So I've plotted the mean with the green color and the variation with the red color. And from the stationarity definition, the conditions we see in the mean and the standard deviation shouldn't change. It should be constant. But here in the graph, we see that it's increasing. So there's a change with different intervals of time. So this is how we implement rolling statistics tests to check whether the graph is stationary, whether the time series is stationary or not. Like I've seen, so there can be many forms. So stationarity is affected by two factors: the trend and seasonality. Here we can see that there's a trend over here. That's why the graph is not the time series is not stationary. So there's many tricks like to reduce a trend, which is transformation. Like for example, in case we can clearly see there's a positive trend, so we can transform the values of the data set. Like we can take the logarithmic or the square root or cube root functions, which is present in this. So here I am applying the logarithmic function for my time series. So here also we see that the graph has changed a little bit. Like this is a new graph. Our previous graph was this. So here we can see there's an increasing trend. But here then the graph has changed. Like there's a change, but still we can't say that the graph is stationary or this. So we will apply the moving average. We'll find the moving average of the time series. So this is another code over here where we are finding moving average of the time series. So in the red, with the red color, I showed the moving average. I meant rolling mean of it. Sorry, really sorry. And then we are taking the past 12. We are taking the last 12 values instead of the first 11 values, because rolling mean is not defined for the first 11 values. Like if we go over here, we see the values are not, there are no values, like there's no values of it, because if when we are taking our windows of 12, like if we see in the other codes I've written the window is 12.
Tejas, I have a question here.
Yes.
Why are you taking the rolling mean? How will it help you? What will you understand? What analysis will you draw from that by taking the rolling mean?
Rolling mean helps us to, it's another this like another test to like check, it's like one of the stepping stones to check a stationarity. So that's why I'm finding the rolling mean of it. So right now, so where were we?
No, but in your slide, if you go back to the slide and you see the definition of stationarity.
Okay. Just no, that's like it's this is the stationarity of
No change in properties over a period of time.
okay.
So which means you take consecutive samples of data of the same sizes should have the same covariances and identical distributions.
Yes,
So
yes.
what is the relationship between a mean and a covariance?
Okay, so when we say mean, we'll have a sample of data. So if we analyze this data, so there'll be a particular mean of the data. And if we say about covariance, so for covariance, we need we compare two sample data and we see whether there's how similar they are, how it is related.
I agree. So I understand. See, most of us understand probably mean, median, mode. So that is okay. So firstly, when we say that we are taking a mean of the this thing.
Okay.
Yeah, Akshat, we'll come to that. There are a lot of there'll be a lot of questions after this, and I'll be straightforward with all of you. This is just the this is the first beginner level, introduction level this thing, introduction to time series. We need to go way ahead of this. All of us together, we need to go way ahead of this because time series is very, very critical to us for that project Python Trader. It is extremely critical to us. We have to go to a great extent and understand these things. So don't shy away from questions. Whatever questions you have, whether they get answered right now or later or whatever it is, you please, everybody keep putting your questions in the chat or keep asking them, or you send them to me later on WhatsApp or whatever. We have to go to a very advanced level of understanding of time series. This is one topic which has to be very, very understood very, very well. So it is okay if now we don't understand, it's okay, but we'll have to do it. So my question is again the same thing. So if mean is there, I understand mean. Okay, you give me a number of this thing observations. I can take out the mean. I can take median, mode. Those things I understand. How do I relate it to covariance? Covariance, to my mind, means that a certain thing is varying in a certain direction. Another thing is whether varying along with it or varying in a different direction. So are they covariates or they're not covariate? How do I understand that?
Like the how covariance and mean is dependent. You're talking about that, right? Hello. Am I audible? I think I lost voice. I think.
No, you are not.
No. You're audible.
I went this thing mute. So we will ask you questions in the chat. You keep seeing the chat. When we talk, otherwise it starts echoing.
Okay. So one of the chats is, what does what does autocovariance measure? So like in the slide, I've seen like autocovariance. Oh, just a second. I think Akshay, I think you meant by autocorrelation. Akshay, covariance. Okay. So basically, covariance is like it's different. Covariance is also like it's a joint variability of two random variables. Here we are dealing with this one. We are dealing with the correlations here, Akshat. It checks even covariance also checks for like whether it has a greater values or lesser values. So it's like a differentiating factor. Okay, so
Tejas, if you don't mind, I would like to add something here to answer Akshat.
okay,
Yeah, so basically, covariance is not an entity that can be measured with respect to a single measuring unit. For covariance, you need to have two things. Let's say quantity A and quantity B, and now you are measuring that how quantity A is varying with respect to quantity B or vice versa. So when you say auto covariance, it's simply that instead of quantity B, you are taking quantity A only, but the quantity A is now let's say shifted for some amount of time. So now you are measuring it with some lag. So like say ki like I'm having that what is the sales today, then I'm saying what was the sales tomorrow, and now I'm measuring how they vary, the variance between them. That is autocovariance.
okay. Okay. Should I proceed with the Jupyter notebook? Okay then. Okay, where is the Jupyter notebook? So if we see in the Jupyter notebook, like go over here, we were finding the moving average. Like first for stationarity, we need to eliminate the trend to find for getting the stationarity of the time series. We need to eliminate the trend of. So here I'm taking a logarithmic function and then plotting it. So here also this is my graph. So this is a time series of it. So, and then so still we are not finding it's not stationary at the our time series. So what we do over here is we find the moving average or the rolling mean, and this is the code for it, like moving average. Like we see, like we are taking the logarithmic value and we are and we're finding the mean of the rolling mean, and and I'm plotting it in the red color. And then I think Basil had a doubt of this, why we are differentiating it. So since we are taking, like if we see of over here the code, like they are like the first 11 values is there's no value of it for a rolling mean. So that's why we are minusing it. Like we are removing the first 11 values and getting the other values. Is my Let me check the chat. Basil, why are we checking the stationarity of the data? So I've given a simple like code, like it's like time. I'm just giving a simple code for like how stationarity is an important factor. So that's why my notebook is the main concept of my notebook is to check how stationarity is an important factor. Okay, then if we go over here, after taking the after removing the first 11 values, we see the graph over. If we check the graph and we compare it with the previous graph over, so we see that there's a drastic change the graph. So there's a time series is like it is little stationary. Okay, we can check. So we have used the we have eliminated the trend and and we have plotted the graph. So we have seen this some sort of stationarity in a time series. Then again, I'll go on and find the rolling mean for this particular graph. So we see that my mean is plotted in red and my standard deviation is plotted in green. So we see that there is a little change, but if we compare it to the previous, like a previous graph where I plotted here, the mean is here. The mean was increasing as well as the covariance, as well as a standard deviation. But here in this graph, we see that the mean is little bit constant, as well as the standard deviation. So we can say like how we can check the stationarity of the time series. So this is my Jupyter notebook. So like this is the end of the presentation. I hope everyone like this presentation.
That's wonderful, Tejas. Thank you so much. Wonderful effort on your part. I really like it. Thank you. Thanks a lot.
Thank you. Thank you, sir.
Okay, I'll quickly share my screen. So there are few things which are there that I need to share. Can you see my screen? There is a pink slide that I have.
Yeah.
I thought let's change the color. We don't do many colorful things, so it's a pink slide. Okay. So few pending things that we need to kind of learn. So this is what I could think of, and Tejas has done an excellent job. He's in second year of BTech. This is more than what I expected from him. So, and I did not advise him anything on the content. He's done this himself. I held back my advice. So he's done it himself, and he's done a good job of it. The few things that I wanted to share with all of you. So what exactly is frequency of a time series? Is anybody aware? How would we say that the time series has a frequency, and what exactly is it? If we are not aware, it's okay. Then we'll have to learn this, and we'll probably next session when that happens, we should have already self-learned most of these things. If there are any issues, you let me know. I'll also try and share a lot of content. There's a lot of content available on Kaggle, on Analytics Vidya, and here and there. 90% of that is total bullshit. Absolutely useless content. People have just gone ahead and put some data somewhere. 100 people have created a kernel on it, and some discussions are going on, random something. Most people don't even understand what they're doing, but just they copy each other's code and just put it over there. So that is not the way to understand this, because this will be our bread and butter going ahead. And Basil said that through somebody, I don't want to mention, he knows a few of these things, which is great. So whether it is your friends, family, anywhere you can get any kind of information, you should understand that and collaborate with some good this thing, some good source. Tejas told me he's taken some of the content from that Analytics Vidya. that some 2016 blog is there. If you go down to the bottom of that blog, I shared that link. So many people are asking so many questions, and by the end of doing all of that, you end up getting confused and frustrated. So no point. So get a good resource to read from, and then okay. Then the third point is log returns of financial time series. Will they be stationary or not? Okay, Rohan has left. So log returns of financial time series, will they be stationary or not? That is one question. And why specifically are we focusing on financial time series? So that is another thing. Because in Python Trader, that's what we'll do. So you'll get lots of time series data within our projects. You might get something with regards to Twitter, which is time series related, financial data, which is time series related. So absolutely anything. Let's say I give you 10 numbers. I give you numbers from 1 to 10, whatever they might be, any random numbers. And so that's one column. The second column, if I go ahead and put some time value over there, I could say 1 day, 1 week, 1 minute, and I could end up splitting that into, regular time intervals. That or irregular time intervals also. In certain cases, there will be irregular time intervals. I might give you the first measurement for maybe the 1st of January. The next measurement I'll give you for 12th of January. The next measurement I'll give you for maybe 25th of Feb, and things like that. So it is not necessarily always that you will have the same kind of frequency. So I've answered my first question. So the frequency will not. Yeah. Basil, I saw that. So it's no. I'm not. See, I'm just trying to. Sorry, if you got me wrong, that's not what I meant. I didn't mean grill in that this thing. I just meant that let's just hold on to our questions. Going forward, we'll have a lot of these sessions. So yeah, don't worry. Please don't get my intention wrong. So yeah, so to perform a linear regression on the original data. So this is a B-level task, in the sense this task probably we'll have to do later on. And what we'll want to understand is that how does a simple linear regression on something of this sort relate back to the time series data, and if there is any relationship over there. Okay, that's why I've said B task. Then plot the residuals after linear regression, plot a histogram of residuals and all that stuff. So okay, that is again a second level task. We'll do that later on. Transform data using the log function, plot the transform data and describe it. This I think already Tejas has done. I don't know why I put it here, but again, we can have a look at that and try and understand why we want to do a log function on it and why are we doing that transform. Then okay, yeah. So similar point, but what's the R squared of the model? What exactly is R square within linear regression? So that will also be a good thing to learn. So like most of you joined later on, initially in the call I was discussing with Rohan and everybody who was there, 5-6 of us who were there. Things like linear regression, logistic regression, all these things we should be quite familiar with. Maybe not the statistical part of it, but at least the code we should understand in Python as to why certain things are in certain way. Then how would you identify outliers in a time series data? So in case we have outliers in a time series data, how do we identify that? And okay, so of course, firstly we need to find a data set which will have outliers. So finding data sets is of course a concern, and yeah, so most of us who are here on the call, if you are yeah, so Akshat needs our help. Akshat also needs some data in case we can share with him for churn analysis. I'll also put that on Slack because he's got 2-3 data sets already and he wants to do a slightly intermediate session for us, and then we want to implement that as one of the modules for churn and survival. So yeah, that is one thing. Just kind of got reminded of that. Yeah, so Akshat needs that. Yeah, of course. So that is one. Then is churn analysis data time series data? So again, this is it's good to relate the concepts that we are working on. If we can relate the concepts we are working on, we have a much more uh, much more in-depth understanding of those. Uh, so let's say. Is churn analysis data or survival analysis data, is it time series data? If yes, then what kind of analysis can we do from a time series perspective? Is Twitter data, tweets and all time series data? Yes, no. Stock trading data, time series data. Can you create bokeh plots from such data? So again, Rohan and me will try and work on this, and we'll get you some kind of understanding on whether it is easy to create bokeh plots or whether it's difficult to create bokeh plots for time series data, right? So this is something I'll note down for Rohan and me. Uh, so some kind of bokeh plots we will have to do. Doing time series data analysis, or visualization with JavaScript is also an option, but again, then we don't prefer that much. Okay, what's autocorrelation function, ACF? I think this is the question which Akshat also had, right? So what is the ACF? And how should we plot the ACF? And once we plotted the ACF, what kind of inference is the word I was looking for earlier also. So the inference that we are drawing from whatever it is that we are doing is very, very important. So we need to draw inference. I should be able to, once I plot something, Basil's question was excellent over there, that why are we trying to do, why are we trying to understand the time series is stationary or not? And if it is not stationary, why do we want to make it stationary by doing a log transform and all that? How does it really help our understanding, or what is it that we want to do with that? So all those things are, we have to draw inference at every stage. Then what's the lag in the ACF again? So I think lag came up somewhere. Tejas already covered that, but still we want to understand. What's the Correlogram in the ACF? What's the partial autocorrelation function, and what do we do? So we plot the ACF, what happens? Then again, this one is related to the linear regression part, and I somehow put it down here. I should have put it up there. Multiple R squared and adjusted R squared. What exactly are these as far as linear regression is concerned? And what do they tell us about the linear regression model? Is it a good model, not good model? What is happening? Then if you take more than one time series data, what is the significance of checking their correlation? So again, I think Basil or somebody asked this question, that if you have more than one time series data, and then you are checking the correlation between them, and I also said humidity and sunlight and all that. So how does that play? And this is where I'll try and put the other questions that everybody's had that I've noted and that are there in the chat, and I'll share with everybody. So now there's 6 of us on the call. If you have any more questions right now, whatever is coming to your mind, you please let me know. I'll note them down. I'll put them on this PDF. And for each and every learning session that we are doing going forward, we'll maintain a Q&A kind of sheet, and we'll share it with everyone so that the questions don't get lost in the chat or whatever. We note them down and we come back to each other and we answer them. So Abhishek, Akshat, Basil, Piyush, any questions that you have right now? Can you hear me?
Yeah, actually, I had something, that whenever we are proceeding with some predictions or anything else, we have two type of models. One is statistical and one is machine learning models. So are we trying to focus our, what can I say, uh, our domain of study on statistical models rather than machine learning models?
I don't understand the difference between statistical models and machine learning models. So can you tell me what is the difference between them?
Yeah, actually, statistical models are those models that are based on inference and mathematical studies. I can say analytical models, and machine learning models are such as, you can say, which like linear regression or logistic regression. Specifically, they develop on these mathematical functions only, but not necessarily sticking to those. They learn, they may have neural networks as well, and then they are made for better predictions. Basically, that's what's the difference.
No, that is not the difference. Can you repeat yourself little slowly and explain to me again? I have not understood.
Yeah, statistical models are basically that are used for inference and using mathematical functions. That's what I understand. And machine learning models are used for making more accurate predictions by building upon those very statistical models, but using some other technologies such as neural networks or some methods that are not very pertaining to analysis.
Again, totally confusing, Abhishek. I'm totally confused though. Okay.
Okay. Okay.
You think yourself what you are saying. Okay. Let me
Yeah.
repeat. I'll repeat it.
Okay.
You are saying, will we look at statistical models which are depending on inference and mathematics? Are
Yeah.
you saying that machine learning models don't depend on inference and mathematics? They also depend
No,
on
no.
inference.
No, I didn't say that. I said that machine learning models are built upon statistical models.
Built upon statistical models.
Yeah.
What does that mean? मेरे को ये बताओ ना. I understand when a house is constructed,
Yeah.
on ground
Yeah.
walls and it is built upon that. What do
Yeah.
you mean by built upon? Machine learning is built upon statistics. What is the meaning of that?
What I'm trying to say is that there is some background. For example, let's say we are using machine learning using linear regression. The model is of linear regression, and
One
then there,
linear regression is statistics. Who said it
yeah,
is machine learning?
yeah. But for training a machine, we can use that model for prediction, na?
Training machine का क्या मतलब? I'm again totally confused. Linear regression, is
Yeah.
it done in an Excel sheet? It cannot be done in an Excel sheet.
Of course, it can be done in an Excel sheet.
Huh. When you say training a machine, what is a machine? Well,
A
first,
machine is anything that takes an input. There's a very famous definition from Three Idiots that anything that simplifies human efforts is a machine.
machine learning is not related to machine. Na, वो तो खाली it's just a term.
Yeah, machine learning is a term that represents that a machine should be able to do.
One
Yeah.
second. Wait. Machine learning is a term which basically means that you have a model which is
Yeah.
learning from data in
Yeah.
a supervised manner.
Yeah. No,
That
it's not necessary that it should be supervised or unsupervised or reinforced. But
who
yeah, it's
told you?
learning. That's
Who
the
told
basic
you?
thing.
One
We had
second.
we are having this subject, machine learning, in this semester. That's where I learned this.
Who's teaching you that subject? In which
Uh,
college?
in our college itself, Institute of Information Technology, Surat. Yeah.
Who's teaching you that subject?
Professor Hemant Goklani, sir.
Whoever it is, what book is he using for machine learning?
The book that he shared some slides with us, and I think he was.
Actually, I don't care. I'm being very straightforward.
Yeah.
I
Pardon?
don't care who is the professor, what slide he has, what book
Yeah.
is he using. Machine,
The slide.
machine learning and deep learning, these have become terms which people, whatever they think, like they keep talking about it. Okay.
Okay.
Machine
Yeah.
learning is very simply that algorithm or a model, a statistical model, has learned something from data in an unsupervised manner. Then you say it is machine learning. People call supervised this thing also machine learning. Then what is the difference between a statistical model which is supervised and
Yeah.
machine learning? There is no difference then. So either you agree that there is a difference, okay,
Yeah.
or you say that it is unsupervised. When I say unsupervised, which means I have given data,
Yeah.
whether it is Canon or whether it is any of these things, whether it is neural network or whatever, given
Yeah.
that it is learning on its own, I have closed my eyes. Maybe some metadata or maybe some hyperparameters I'm tuning.
Yeah.
Besides that, the machine has learned on its own.
Yeah. I understand that. So I
Now,
totally agree with you, but
one second. Second
yeah.
thing,
Yeah.
what book are they offering? There are thousands of books which have been written on machine learning. Not all those books are correct.
Okay.
So you have to go back. You have to go back to the initial books which were written and
Okay.
why they called it machine learning. You have to understand. If from
Yeah.
that understanding there is a problem, then we have to debate it further, because thousands of people in the world are debating this only. What is machine learning? What is deep learning? Whether to use R, whether to use Python, whether to do this, do that. And
Yeah.
I don't want to go into those debates. Okay. My
Okay.
understanding is very clear, and I will keep my understanding to that only.
Yeah. Yeah.
unsupervised learning when I give data to a model and I close my eyes and I sit back, and that model learns from that data in an unsupervised manner. Then I call it machine learning. If I have to intervene and I'm doing
Yeah.
some supervised thing, then it is not machine learning. Then it is traditional statistics.
All
And when you
right.
say it is built upon, that built upon is again a very loose definition. Uh, what exactly do I mean by built upon? In a neural network, if I have something which is a sigmoid function,
Yeah.
does that sigmoid function not exist in core mathematics? Does it not exist in statistics? It exists, right?
Yeah. That's what I was meaning by built upon, that it is extracting those cores from there only.
So that it is the same thing, Nayar. Just because people have been doing it for 60 years, 70 years, and
Yeah.
nobody has noticed it, and suddenly you want to make it, you want to make students notice it, and you want to make people notice it, you give it a different name, and you start using it. That doesn't make a difference. So it has to be something in the paradigm itself. So if it is unsupervised, and if it is unsupervised to the extent that you provide data, and
Yeah.
beyond that you don't do anything, you just provide data, and from that itself the machine has learned, then in a classical way you'll say yes, it is machine learning. Otherwise it is statistics, applied mathematics.
Okay. So
Applied mathematics.
I got your point. I got your point. The point is that I have some understandings that are not exactly aligned with your understanding. So I think I'll have to refine myself. Yeah. I'll learn.
No,
And
no, you don't have to see. That is my point again. You don't have to follow my this thing. Um,
no, I got your point. The point is that if you are saying something, I'll have to look from that perspective also, na? That that's what is that's what is science is.
Akshat is saying statistical models are designed to for inference about the relationships between variables.
Yeah.
Akshat, that is not that. It is not only inference between variables. Statistical models are also predicting. Who says statistical models are not predicting? Most accurate prediction possible. Again, a simple static. And okay, you tell me, is neural network a statistical model? Neural network is not a statistical model. Or is support vector machine not a statistical model? Or is random forest not a statistical model? Or classification trees, regression trees, are they not probability trees? Are they not statistical models? Just because some company spends billions and billions of money and comes out with something like TensorFlow or PyTorch and all that, we start believing that those are the only things that work, the other things don't work. You think a neural network is not written in the language R? Neural network only happens within TensorFlow or PyTorch. Have you seen a neural network in the language R? Have you seen it? This is, we have to understand what we are getting into. And I don't say that you have to believe what I'm saying, but what I'm saying, you please go and Google that. And if you don't find it over there, then I could be wrong, because I did not make these things on my own. I myself Googled them, I studied them, a professor taught me, a professor from Delhi University taught me, three professors from Northwestern University taught me, and they have taught me, in our classes, they used to laugh at IBM. A company like IBM, these guys to laugh at that company and say, what a useless company and what useless work these guys are doing. And we were shocked. We were sitting over there and we were shocked. How can they do that? Then they showed us proof, saying that look at this, look at this, look at all these things which have historically happened. So big companies will do things from a marketing perspective also. It is not necessary that they own the statistical theory. Neither do they own the statistical models. We have to ourselves make that judgment. We have to make that judgment. So what books you are reading? Again, you calibrate yourself. That's okay. So if you don't agree and if you don't discuss these things, there's absolutely no point of us having a discussion. We should have this discussion. This is what is required.
Yeah, actually, I'm really glad that I got to know this. I honestly, I didn't know that there was this debate going on, that statistics be that way differentiated from machine learning. Now I look into this seriously. That's what I was saying. That uh, it's good that we had this discussion, and this is science, that you are open to all thoughts, and then you think from all perspectives and then make a decision and arrive on a conclusion.
Yes, that is required. That's called rational decision making model. Okay. A
Exactly.
human being, we are supposed to have a rational decision making model. You observe as much as you can and then draw a conclusion saying that this is what it is. And we are in no hurry to draw conclusions. I'm not that kind of guy who will tell you, okay, isko jaldi se, let's fix this, let's do this, let's have a solution for this. No, never. I will not do that. So
Exactly.
if we are in this group, we are here to discuss openly and
Yep.
have a dialogue.
Yep.
The Latin word dialogus, they call it dialogue, means we need to have open discussion from both sides.
Yeah.
It can one side this thing. So yeah. So maybe maybe your college book is right. Maybe your professor is right. I don't know, but we will have to explore that together. Let's not
Yeah.
blindly just what is happening.
Yeah, sure.
Perfect. Yeah. So in case we are okay with today's session, we can now close the call. And thank you so much. Thanks a lot. I love these discussions. Thank you so much for having such a open discussion. And Akshat, yeah. So maybe I don't know. I'll have to check what I'm saying. Maybe the most accurate prediction comes from machine learning. That is okay. But statistics is not only for inference. There are predictions which are happening there also. And if a neural network or any of these things, if a logistic regression is not predicting, I really don't know. Then that's the reason why it's there. It does a decent job of prediction. And there's so many models, not only a logistic regression, not only a linear regression. There are so many things in statistics which people don't really bother about nowadays. But yes, there is a lot of value in that. There's still a lot of value in that. Perfect, great. Anything else you guys want to discuss? Yeah, so Piyush is saying ML is essential form of statistics. I can't say. See, I will not be able to define these things. But as far as I know, machine learning has got to do with unsupervised, algorithms. When I say that machine has learned, I presented the data, and it in an unsupervised manner, it draws its inference. Basis that inference, it reacts to data which is not seen. So to the unseen data, or to the test data, or the holdback, or whatever it is that we want to call it, or the real world data when it turns up, the machine reacts to that. Or when I say machine, let's not say machine, let's say the algorithm. The statistical algorithm reacts to that once it has been trained in a unsupervised manner. That is the only difference which I can think of between statistics and machine learning. Otherwise, I don't even know there is a difference. As far as I know, there is no difference. I recently saw some Indian person having written a book on supervised this thing, and I asked them on LinkedIn also. I said, yeah, why are you guys doing a book on supervised this thing? Nobody cares, nobody cares about supervised. Everybody cares about unsupervised. Blindly throw data at something, let it learn on its own. Let's wait for so many epochs, and then things will happen. So that person said, no, supervised is still very important in so many industries and this and that and all that, which is great if that is there. So yeah, why not? So there's a lot of discussion. There's a lot of different views on all of this. So let's see. I can't make any blanket statements. I don't want to make a blanket statement saying that this is what it is and this is what it is not. So really can't say. So this is my understanding right now. My understanding might change in the future. Great. Thank you so much. So we'll finish the call. It's got extended, and we have Yeah, thanks Piyush, thank you Tejas, thanks Akshat, thanks Bisil, thanks everybody for sticking around till the end. Thank you so much.